Hey guys, and welcome back. Today we'll be taking a look at a portable power station from EcoFlow. This is the River 3 Plus, a recent addition to their power station lineup. I was just casually browsing around the other day and I came across this model with one feature in particular that caught my attention. It's advertised as a UPS, but more on that later. Let's take a deeper look and see what we got. In the box, we have our power station. Obviously, just picking this up leaves a great first impression. It just feels solid, like a premium product. We have our AC power cord, and this is actually a pretty nice cord. It's 14 gauge conductors. Typically, a lot of devices these days will come with like a 16 or 18 gauge. Additionally, this cord is ETL listed, so that's a good sign as well. We have a USB cable for connecting this to a computer, and then we have our car charger for a 12-volt accessory port, and it's just got an XT60 on the other end. On the front, we have a very nice looking display. We have input wattage, output wattage, the current battery state of charge. This is at 78%. We have a 12-volt car accessory plug. We have two USB-A's, a 100-watt USB-C, a single AC output. We have a power button for the device itself, and separate on-off buttons for both the DC output and the AC output. Lastly, we have an LED strip light across the bottom, which I feel is positioned perfectly for lighting up your workspace if you're working at something on the bench. So we have a low mode, a high mode, and then we have a strobe mode. On the back, we have two additional AC outputs. There's a small door that slides down, revealing the AC input, the DC input, which again is an XT60, and the USB connector for your computer. On to the technical specifications. This power station has a 286 watt-hour lithium iron phosphate battery rated for 3,000 cycles to an 80% state of health. That means you can cycle this thing every day for over 8 years. It features a 600 watt inverter with X-Boost capabilities. Again, more on that later. The AC charger will max out at 380 watts, providing a full charge in less than an hour. The DC charger is good for 11 to 55 volts and will max out at 220 watts, providing a full charge in approximately 3.5 hours by car or 1.5 hour by solar. Alright, that was a lot of talking, so let's move on to some actual testing. First up will be a capacity test, and we're going to do that at the AC output. We want to see how much power is actually usable from this battery. Now, keeping in mind there will be some efficiency losses here with the conversion from DC to AC. This is not a 100% efficient device. That doesn't actually exist. So there's some conversion losses. There's some losses with, power to run the unit itself. There's a fan on the side. So I'm not expecting to see 286 watt hours of actual usable energy. With these power stations, around like 85% or so efficiency is pretty typical. The power station is fully charged. You can see it's at 100%. It has been plugged in for a couple of days now. I have an energy meter here on the right. I have an extension cord connected with just a few LED lights and so forth. So I'm going to go ahead and unplug the AC input. Going to turn on the AC output. On the power station, you can see we're pulling 67 watts and it's calculating 3.8 hours of estimated runtime. On the power meter, we're showing 66 watts, so I'd say it's pretty darn accurate. I'll just leave this run until the power station shuts down and then we'll see how much energy we used. There we go, it just shut down and it was at 200, I think it said 242. Let's go ahead and plug the AC power back in just to verify that. So we can stop this. Maybe we have to leave it charged for a little bit before it'll turn back on. As the lights blink in there, oh, it just clicked. 242 watt hours at 3 hours and 33 minutes. Earlier I mentioned that this power station has X-Boost, but what is that? The inverter is rated for 600 watts of power output with 1200 watts of X-Boost. They are very careful with how they word this, and it's important to understand the difference. The 600 watt rating is continuous power output. You can power 600 watts of load with this power station. Now you can run loads up to 1200 watts, and that's what the X-Boost is, but there's a catch. You're running those loads at reduced power. Once you hit 600 watts, and if you have X-Boost turned on, the inverter will actually start to drop the output voltage, and it's doing that to allow you to power your loads that are rated more than 600 watts, but you're still only getting 600 watts of power out. This works great for resistive loads like a hairdryer, a toaster, coffee pot, I guess. It'll just take longer to dry your hair and it'll take longer to toast your bread. I wouldn't use like a microwave or an air conditioner or anything like that. Now I'm going to demonstrate how this works and then I'll probably shut X-Boost off on mine. If I plan to power loads greater than 600 watts, I'm going to select an inverter or a power station that's appropriately rated for the type of load that I'm trying to run. To demonstrate how this works, I have my voltmeter plugged into the back AC output here, and you can see we're reading 119.6 volts there. I have a small load, it's just some LED light bulbs, the same lights I used for the capacity test. We're pulling 68 watts now, and our voltage is still at 119. Next up, I have my heat gun here, and this is rated for 750 watts on low and 1500 watts on high. Now watch what happens to the voltage when I turn this on low. So the output is showing 600 watts even, and our voltage is down to 105 volts. So let's do the same test again here, but let's run it on a high, which is rated for 1500 watts. Okay, it's still running. It's showing 668 watts on the inverter, and it's showing 81 volts on the AC output. And let's just leave that run for a little bit and see if it actually trips the overload here, because that is in excess of the 1200 watt rating. Oh, there it goes. It did trip. So it says overload, it shut the AC output off, and I got error code, what is that, 502 there? So I think that demonstrates exactly how the X-Boost works. All right, so I have a 330 watt solar Boviet panel plugged into this EcoFlow here. It is 330 watts, like I said. It's about 46 volts open circuit. So this is pretty much as large as I would risk plugging in there. It leaves a little bit of overhead. I'm charging it just under 200 watts. It did peak out around 220. And you can see there it's dropping to about 82 watts now. Next, we'll take a quick look at the UPS functionality. I'm going to go ahead and plug in my desktop computer here in the back of it. We can see here that the power station is taking 455 watts in, and it's putting out approximately 118 watts, so the difference is being used to charge the battery. We can see on the monitor that the computer is started up, so I'm going to go ahead and disconnect the AC input from the EcoFlow. And we can see the computer is still running. I should be able to simply plug this back in. And now we're seeing power on the input, so it's back to charging the battery and powering the load. Meanwhile, the computer is uninterrupted. The documentation from EcoFlow states the transfer time from AC to UPS mode is less than 10 milliseconds. This is a big step up from the original EcoFlow River Pro that I reviewed, what was that, 3, 4 or more years ago at this point. And the original was rated for 30 milliseconds transfer time, not something you'd want to run a computer on. Additionally, another difference is that this one actually has a ground pin on the AC output. And I know that sounds silly to say because yeah, there should be a ground pin on it, but the original River Pro only had a neutral and a hot. It had a hole for a ground pin, but there was no actual pin or conductor for the ground on the AC output. And if I take my ohm meter here and I put one lead in the front grounding pin and one lead on the back grounding pin, we can see I do in fact have continuity. So even when the grid power is off and this is running in UPS mode, because your input cable is still connected, anything plugged into the AC output is still connected to earth ground. One additional thing to note with the UPS mode is that if you connect your USB cable from the power station to the computer, you can install the EcoFlow software and monitor some basic statistics such as the input wattage, output wattage, and so forth. There's also a key piece of functionality in there. So let's say you lose power and you're not home and I've got my desktop computer plugged into this power station here. Well, if the battery starts to run low in the power station, that communications will actually allow your computer to shut down safely. That way you're getting a safe and complete shutdown rather than this just switching off because the battery's dead. There are a lot of other things that a typical UPS, like if you go out and buy one from APC, that those UPSs do that this one doesn't. For example, this one doesn't really do any voltage regulation. It's not like a double conversion UPS. I can't find any documentation as to where the cutover points are. What voltage is considered too low, what voltage is considered too high before it switches on to UPS. But this is absolutely perfect for a desktop computer, a home office setup. It's good for like a NAS if you have a network attached storage. It's perfect for that kind of use. Real quick, because this video has gone on long enough, EcoFlow does have an app to manage this power station. Every device under the sun seems to have their own app these days. The app is not required to use the power station. However, there are a few settings in there that may be of interest. For example, you need to use the app if you wish to turn off the X-Boost functionality. Other settings include adjusting the front display panel timeout and setting the DC input charger type. By default, the DC input is set to automatically detect between car charger and solar panel. I personally am never going to use the car charger for this device. If I connect anything, it's going to be a solar panel. And I think if it were set to solar, I probably would have seen more than 82 watts when I plugged in that 330 watt panel outside. I think this will make an excellent UPS, and that's where mine will live out the rest of its days. I really needed to get a UPS on that computer, but I got tired of replacing lead acid batteries and only getting 2 to 3 minutes of runtime. There are two minor things I'd like to see as improvements on this device. I really think it needs a second AC output in the front. It does have two AC outputs in the back, and that is great. I don't want to eliminate those, but I really think it needs a second output in the front, just as a matter of convenience. Also, I think an adapter should be included to connect a standard solar panel. I love the XT60 for the DC input. That's a perfect connector choice to use for a DC input, but a standard solar panel has an MC4 connector. Now, EcoFlow does sell an MC4 to XT60 adapter on their website, but for the $2 or $3 it probably costs them to make it, just include it as an accessory in the power station. Even if it drives up the cost of the power station bundle by $2 to $3, I'd much rather have that cable included than purchase it, find out it's not included, and have to go back and buy a separate part later. Anyway, please let me know what you guys think. If I run into any issues using this as a UPS, I will certainly follow up and let you know. Hit that like button before you go, and thanks for watching.